Alright, so in the prior video, we took a linear system, right here, and we turned that into an augmented matrix that we have right here. And so in this video, I'm going to row reduce this matrix, and we're going to see if we can find a solution to this matrix. And that solution is going to correspond to the weights x1 and x2 that made this linear system above true. Alright, so how do I do that? So first step I'm going to do is I want to get rid of this guy right here. This -2. Okay, so what I'm going to do is I'm going to do 2 times row 1 and I'm going to add it to row 2. So what does that get me? So the top row is going to stay the same. And admittedly I'm going to try to do this pretty quick. So 2 times row 1, well the first entry is 1, so 2 times 1 minus 2, that is equal to 0, so that's good, that goes away. 2 times 2 is 4, plus 5 is 9, so that becomes that. And then this is going to become -5 and 6. And then I have one last thing to do, so 2 times 7 is 14, plus 4 becomes 18, right? And then this guy down here, this in the third row, we didn't affect that, so that just stays the same. So now, how do I get this to the next step? So what I'm going to do here is I'm going to say 5 times row 1, and I'm going to add it to row 3. So what that's going to leave us with is a 1, 2, 0, 9. Right? We're not affecting these rows. They're staying the same. 18. Okay. But now we're saying 5 times row 1. So that's 5, and then we're subtracting 5 from it, so that's 0. And then we're saying 5 times row 2, or 5 times row 1. In this case, the next place we're going is 2, so that's 10, and we're going to add that to 6, which is going to get us 16. Okay? And then we're going to say 5 times this 7 right here in row 1 is going to be 35. And we're going to add that to -3, and we're going to get 32. Okay. So now where do we want to go? Now we want to get rid of this 16. But before I do that, I'm going to actually just simplify this guy just a little bit. Okay. And I'm going to do that by dividing row 2 by 9 and dividing row 3 by 16. Okay, so this is going to be, so I'm going to divide row 2 by 9, so 0 divided by 9 is 0, 9 divided by 9 is 1, and then 18 divided by 9 is 2. And row 1 staying the same, so that can stay there. Okay, and then 0 divided by, in row 3, we're going to divide that by 16. 0 divided by 16 is 0. 16 divided by 16 is 1, and 32 divided by 16 is 2. Alright, so again, now that we've simplified this, we want to get rid of this guy, so how are we going to do that? I'm going to move this to over here, and I'm going to say -1 times row 2 plus row 3. Okay, and what is that going to leave us with? That's going to leave us with, well, the first 2 rows are staying the same. Okay. That includes that right-hand side. And so -1, so in this first element right here in row 2, in this first entry, we have 0. So -0 plus 0, well, that's just 0. And this next one we have 1, so this becomes -1 plus 1, right? So this is coming from row 3, this is coming from there. That becomes 0. And then in our last one, we're saying we have this 2 in row 2, we're multiplying it by a -1, and then we're also adding it to the 2 down here, so that just becomes 0. Okay? So what we have right here is our simplified form this is in echelon form. Now remember, echelon form is good to tell us some things about existence and uniqueness. And if you can think back to those videos when we first introduced existence and uniqueness, what we can tell from this augmented matrix is that a solution does exist, right? And the reason why we know that is because, remember, in the video where we talked about existence and solutions, when we learned that theorem, we don't have any row that looks something like 0, 0 is equal to some constant, right? We have this bottom row which has just all zeros in it. So we know a solution does in fact exist, okay? But now we want to ask ourselves, is this solution unique? Is it the only solution that we can come to? And what we need to look at is we need to see if we have any free variables. Okay, so are there free variables? And if you remember, what we said free variables were places where variables showed up in more than one row. Okay, where one of these guys, A1 and A2, in these columns we had a variable a coefficient, excuse me, I shouldn't say variable, a coefficient show up in more than one row. And we can see that right now we have this coefficient here, right, 1, and we have this coefficient here, 2, and then we have all zeros underneath here, right, so we're in this kind of nice little triangle. Okay, but we have this this A2 right here, this coefficient for A2. So it might seem like, hey, that there could be free variables here because we have we have an A2 here and an A2 here. But what we need to do is take it one step further to really determine if this is a free variable, and we need to get to reduced echelon form. And the way we do that is by kind of working backwards. We work up the matrix. So before we worked down the matrix. Now we're going to work up the matrix. Okay? And so to do that, we're going to take this matrix that we have right here, and I'm going to say negative row 2 plus, negative 2 times row 2, and I'm going to add that to row 1. Okay? And let's see what we get here when we do that. So, when we do that, what we get, this should be a 7. Sorry, that looked a little weird there for a second. When we do negative 2 times row 1, negative 2 times row 2 plus row 1, well, we're going to get, the bottom is going to stay the same, right? We're not affecting that. And the middle is going to stay the same because we're just using that in our operation, but we're not changing it at all. So the top row is the only thing that's going to change. So this bottom one, this first entry is going to be 0 times negative 2 plus row 1. Well, that's just going to be 0 plus row 1, so we're just going to leave that 1 there. Now our next element is going to be negative 2 times 1, so that's negative 2, plus 2, so this becomes zeroed. Okay? And then finally we want to do that right-hand side as well, and so we're going to say negative 2 times this 2 right here, and we're going to add that to 7. What are we going to get when we do that? We're basically saying, what is 7 minus 4? Right? Because we're going to get negative 4 plus 7. So it's the same way as thinking of 7 minus 4, and we're going to get 3. Alright, and so now that we're in reduced echelon form, we can see that each one of these equations, okay, has only one coefficient in it. Right? So this really equates to this right here. So this equates to 1 x1 and equals, right, because there's no x2 term in this, equals 3, and then we have 1 x2 is equal to 2. Alright, and basically we can kind of just look at this and say, alright, x1 is equal to 3 and x2 is equal to 2. We have no free variables, alright, So it appears that we have a solution, and our solution is in fact unique. Right? And so now let's go ahead and let's bring this back to where we started when we looked at this as an equation of vectors, a vector equation or a linear combination. So how do we look at that then? So what we're going to say is x1 is 3, and we had our vector 1, -2, -5, and then we add 2, alright, and 2 was equal to 2, 5, 6, and that is equal to, is equal to 7, 4, -3. Okay, and I will leave it to you to verify using the properties that we learned in two or three videos ago to verify that that is actually true. Okay, but to recap really quickly, what did we just do? We just showed, we answered our original question, right? We showed that B is equal to 7, 4, and 3 could in fact be generated using a linear combination of A1 is equal to 1, -2, -5, and A2 is equal to 2, 5, 6. Awesome. Alright, so in the next video I'm going to go over kind of like a general idea, just to kind of formulate what we did, just formulate the connection that we just made in this video, and a little bit of a definition.